Word science probably brings to mind many different pictures. A fat textbook, white lab coats and microscopes, an astronomer peering into a telescope, a naturalist in the rainforest, Einstein's equations scribbled on a chalkboard, the launch of the space shuttle, bubbling beakers. All of those images reflect some aspect of science, but none of them provides a full picture because science has so many facets. But one thing that everyone knows, that science is everywhere.
Motion in one dimension or one-dimensional motion is motion along a straight line. The line used for this motion is often the familiar x-axis or x-number line. The object may move forward or backward along this line. Forward is usually considered positive movement, and this movement is usually considered to be the right. Distance. Distance is a scalar quantity that refers to how much ground an object has covered during its motion. It also refers to the amount of space between two places or things. A point or place that is far away from another point or place. To compute distance, add all of your distances using the GFSS method.
2 hours later, 3 hours later.
Can you move it along? I'm all out of time cards.
Displacement. Displacement is that what tells about the change in position. It is a vector and is the overall change in the position from the reference point. It is the shortest distance between the initial point and the final point. It prefers straight line path over curved path and is a vector quantity. There is no single formula for displacement. It depends on the other quantities present in the problem. Still, there are few formulas using which we can find the displacement. Go! Velocity. Velocity is defined as a vector measurement of the rate and direction of motion. Or in simple terms, velocity is the rate and direction of the change in the position of an object. The scalar magnitude of the velocity vector is the speed of the motion. In calculus terms, velocity is the first derivative of position with respect to time. To calculate velocity, just simply divide the distance to time.
Acceleration. Acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. An object is accelerating if it's changing its velocity. Anytime an object velocity is changing, the object is said to be accelerating, while when the object is slowing down, the object is said to be decelerating. To find the acceleration, find first the difference of final velocity and initial velocity. Then, divide it to the difference of final time and initial time.
2,000 years later.
Careful, it's spinning out. Wait. So heavy. Look, there's a wave. Wave? What is wave? Do you want to know what is wave? Yes. Watch this.
Talking, playing to a guitar, cooking, watching TV shows in cable shows an example of waves. Waves involve the transport of energy without transport of matter. In conclusion, a wave can be described as a disturbance that travels through a medium, transporting energy from one location to another location without transporting matter. There are two types of wave: transverse waves and longitudinal waves.
1 p.m. The next day. Later. 20 minutes later. 6 hours later. Several.
Electromagnetic waves are used to transmit long, short, FM, wavelength radio waves, and TV, telephone, wireless signals or energies. They are also responsible for transmitting energy in the form of microwaves, infrared radiation, visible lights, ultraviolet light, X-rays, and gamma rays. Cooking in the microwave is one of the examples of electromagnetic waves.
Thousand years later. 6.5 hours later. A few inches later. Day 2, day 3, day...
There are many types of waves, but this type of waves require a medium to travel. Mechanical waves include many waves such as sound waves, water waves, ocean waves, earthquake waves, and seismic waves.
Under the mechanical waves is a transverse waves. A transverse wave is a moving wave that consists of oscillations occurring perpendicular right angle to the direction of energy transfer or the propagation of wave. If a transverse wave is moving in the positive x direction, its oscillations are in up and down directions that lie in the yz plane.
Travel through the air or any medium and can be heard when it reaches the person's An animal's ear is called sound. There is three different characteristics of sounds: the pitch, the loudness, and the quality. To learn more, watch this!
The food is here.
Music, maestro. Oh, my heart is like a balaunala. Oh, my heart is like a balaunala. Oh, my heart is a bala. Oh, it's a balaunala. Habanaunala. Oh, ya bala, ira balaunala. Oh, my heart is a balaunala.
Pitch is one of the elements of music. In sound, pitch is a perceptual property of sound that allows their ordering on a frequency-related scale, or more commonly, pitch is the quality that make it possible to judge sound as higher and lower in the sense associated with musical melodies.
Loudness. Loudness is the attribute of a sound that determines the magnitude of the auditory sensation produced, and that primarily depends on the amplitude of the sound wave involved. Sounds may be generally characterized by pitch, loudness, and quality. Sound quality or timbre describes those characteristics of sound which allow the ear to distinguish sounds which have the same pitch and loudness. Timbre is then a general term for the distinguishable characteristic of a tone.
Science is action.
Science is everywhere.
Where's other?
Bluebird.
Okay, what? Ulit. Okay.
Ulit. 1, 2, 3, go.
Bulaga.